go. We got that. This thing here. Okay. Excellent. All right. Here we go. Hello. All right, we're on there. There you go. Hello, hello, hello. All right. Sure that that's not done like that. Okay. Good stuff. We'll see how it goes. Hello, 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 everybody. Hello. Oh, jeez. Hello, everyone. I hope everybody's doing okay today. All right, here we go. Hey, how's it going, Brenton? Good, good. Did you have a good weekend? Hey, how's it going, Dr. Dan? I like that. Hello, hello. All right. Yeah, I had a pretty good weekend. It's pretty productive. It's pretty happy. Um, man, good to see everybody in here. All right. Excellent, excellent. Yes. How is everybody doing? I hope they're doing good today. All right, all right. Okay. All right. We're going to go ahead and get started here. So let's go ahead and get going here. All right. Let's do this. Okay. Hopefully everybody's ready. All right. Okay, let's get started today. Welcome back to Monday. Hopefully you have a nice weekend. All right. So again here today, we're going to pick up where we left off last time. All right, everybody. Last time we talked about the beginnings of fractions. All right, we discussed exactly what that was all about. Okay, we again talked about, hey, okay, there's fractions. All right, we talked about dividing, multiplying. Okay, talking about the basics of fractions. Now, we didn't go over one part of fractions here, the part that I do want to kind of focus on here today, and then we'll get into the next chapter as well. All right, which is talking about adding and subtracting fractions. Okay, so that's what's on the agenda here for today. Um, Before we get started here, does anybody have any questions that they would like to ask? Okay, so just making sure that everybody is okay. If they do have a question again, just feel free to ask. But yeah, if there's any questions over the weekend, then that's what that purpose is for. Okay, in any case, let's go ahead and talk about a couple of things here. Oh, okay. So you could get that on mymathlab.com. Okay. So if you have a credit card there, you can go ahead and purchase that. So hopefully that'll help. Any more questions? No? Okay. So I'm going to try something here today. See if I can get this to work out. So, okay. Okay. I'm just trying out something new here. See how we can work with this. So, all right. There we go. Okay. So, what we're going to be focusing on here today is, like I said, we're going to talk about adding and subtracting fractions here. So let's discuss how to add and subtract fractions, okay, first and foremost. So let's go ahead and give that a go. All right, let's at least expand on this. All right. Okay, so adding and subtracting fractions is going to be, again, what we'll focus on here in this section. Now let's discuss about how to add and subtract fractions. So there's two types of fractions that we want to look at here in this particular case for this section. We're going to first talk about like fractions. Okay, now what are like fractions? Like fractions are fractions that have the same denominator. So if you have the same denominator in all the fractions, those are going to be what we call like fractions. So for example here, like fractions would be, say, these two fractions would be like fractions. So 1/8 and 3/8. Those are indeed like fractions, okay? No problem, all right, because they have the same denominator of 8. Okay, so again, Now, of course, the opposite of that is unlike fractions, all right? And of course, fractions that have different denominators, unlike fractions. Now, the important part here is that although these are the basics of course, what we're going to be doing here, the part that we want to focus on here and why I kind of talk about this is because like fractions is what we want to be under. So let's talk about the first key here at the very least, because there are several. So the key here, first key that we'll talk about is if we want to add or subtract fractions, they must be like fractions. So if they, so again, AKA, they must have the same denominator. So we cannot add or subtract before we actually see if the fractions have the same exact denominator across the board. All right. So that's going to be one of the biggest things that we're going to be looking at here in this section. All right. So how does it work for adding and subtracting if we had like fractions? Well, let's take a couple fractions here. Just a really quick one. Let's say I had 2 over 11 plus 3 over 11. Okay. And so if we have that, all we have to do here is just add 2 plus 3, and then you keep the 11 the same. So again, you keep the denominator the same, you just add the numerators together, just like so. So in general, if you're adding or subtracting here, regardless of whatever it is, let's say, again, let's go with this here. Let's say you have A over C plus B over C. Keep the denominator the same of C, but then just add A over B. And of course, you can repeat this process here once again with subtraction as well. So if you subtract, just subtract those numerators from each other and keep that denominator. Okay, so these are the two generic rules here that you can apply for anything. Okay, so of course 2 plus 3 would be 5 here, for example, and that would be your final answer in that case. So okay, just as a side note here, really quick as well, so that way we're getting this stuff out of the way. One of the other things to note here, note is to reduce at the end if necessary. So sometimes you add or subtract, and sometimes it does reduce out. It just depends, right? So again, we don't know, but you know, it's a thing. All right. Okay. Yeah. All right. So we got that. All righty. Easy peasy. Now, let's talk about, let's see here. Okay. So let's talk about what happens if we have unlike fractions. So like fractions here are pretty straightforward, okay? It requires very little effort to do with like fractions. Unlike fractions, though, a little bit of a tougher story. So we're going to talk about a couple of other things here for unlike fractions. Okay, so let's take a good example here and add up some unlike fractions and talk about how to actually solve for that. Okay, all right, so let's see here. Let's come up with one. Okay, so let's go with 1/2 plus, let's go with 3/8. Okay, let's go with 1/2 plus 3/8. Okay, So 1/2 plus 3/8, and let's say we want to figure out what that's going to be. Now, let's be realistic for a moment here, okay? To be as realistic as possible, some places like a shop is going to have posters along the wall to talk about, say, fractions and whatnot. But sometimes you're like, okay, I got a 1/2 inch hole, I got a 3/8 inch drill bit, okay, things like that. Hi, Maria, how are you? Um, and sometimes you just want to add those two together. Okay, well, let's see how we can actually, see how much more purchase we have if we add, another, say, 3/8 of an inch or whatever. That's very good. I'm very good, Maria. Very, very good. Learning some fractions here today. Okay. Now, as it says here, we want to have like fractions at the end of the day. So we want to have the same denominator. We're learning about how to add and subtract some fractions there, Maria. All right. So how do we get the same denominator here? That's the most important part here in this particular case. All right. How do we get the same denominator here? Well, what we need to do here is, let's talk about the key here in this case. So the key here in this case is going to be, again, we want to find the common denominator. Okay. We want to find the common denominator. Okay. Now let's talk about what the common denominator is. The common denominator is the least common multiple between all the denominators of all the fractions. Okay. Now, I'm going to stress this a little bit, and I'll make a note after this as well. So, just to make things easier. Okay. Okay. So, let's talk about this here for just a second. Okay. Let's look at our example out here. We got a 1/2 plus 3/8. All right. What is the common denominator between 1/2 and 3/8? What is the common denominator? Yeah, what do we have here? What do we have? 2, we have 8. So what's the common denominator there in that case? What do you guys think? Yeah, 8, okay. Okay, so I get one answer of 8. All right, what else? 16, okay. All right, any other guesses? That's fine. Is it 8? Okay, Maria says 8. Any other guesses here? You got Dan the man. Yeah, doctor's in the building. 8, okay. Okay, good. So the answer to this is going to be indeed 8. That is correct. Now, let's talk about why this is. Okay, so we had 8 and 16, and sometimes when people kind of answer this, they say, well, the answer is 2. Sometimes they'll answer that. Well, the one thing I don't like about the definition about the common denominator is the word least. So I kind of don't want you to think in the words of, say, least per se. So it is the smallest said one, obviously, but the way you just basically not confuse yourself is you take this note into account here. So a very important note that I'll put down here, at least for common denominator's sake, is going to be um, the common denominator, and I'll put CD for short. The common denominator is always the largest denominator or higher. Okay, so we actually use the like multiples of the largest denominator, which is starting from 8. So why is it not? Well, it can be 16. Okay, that's possible. So the answer is it 16? Like, yeah, it's possible. but then you'll have to do an extra reduction at the end. So you could make it that way if you want, but you'll have to reduce it at the end of the day, and that makes things slightly a bit more complicated. So to reduce the amount of work on yourself, you want to go ahead and be like, all right, cool. Let's start at 8, and you just ask, okay, does 2 go into 8? And the answer is yes, 2 does definitely go into 8. You don't have to question if 8 goes into 8 because any number goes into itself. So just ask, does 2 go into 8? Yeah, it does. All right, fine. Okay, so we got that. Now, let's talk about the part here that also you just have to be careful about. Remember, if we're going to add or subtract fractions, we need to make sure that they all have the same denominator of 8. So what we're going to do here is we're going to talk about the second key here, key number 2, which is, of course, to multiply the numerator and denominator by the same number so that the denominator equals the common denominator. Okay, so again, one of the things that we talked about here in algebra is algebra always comes around in the word of balance. So if we talk about the word balance here once again, well then balance here is going to play another role. Again, here we have 1/2, okay? So we go with 1/2. Well, what do we have to multiply this 2 by in order to get 8, if that's our common denominator? Okay, that's correct. The answer is definitely 4. So we multiply by 4 here, and we also multiply by 4 here. Okay, so because, again, we're balancing everything out. If we multiply the denominator by 4, we multiply by the numerator by 4 as well. And then we go ahead and put this together. Okay, so we get 4 over 8 after multiplying that out, plus 3 over 8. And then we go ahead and add those together there, which is going to be, again, 4 plus 3 over 8, which equals 7 over 8. And there we go. Got it. Nice. Okay. All right. Great. Any questions about that? Any questions at all? Do another example. Nope. Okay. Let's go ahead and do another example. Okay. So really quick here. Then we'll get into some applications here. So I just want to talk about the basic concept here. So you'll also encounter here in this section with mixed numbers. So let's talk about how mixed numbers will work. Okay. So let's go with 1 and 1 and 1, 1/6. Sure. Okay. Let's go with that. So let's go with 3 and 5/8 and 1 and 1/6. Okay. So let's talk about if you encounter mixed numbers that you have to, again, add or subtract with. In this case, we're doing subtraction. So, okay. Now the process is exactly the same with the only added bonus here of this. So let's talk about this here. Note, if you see a mixed number, change it to an improper fraction first. Okay, so we're just going to change these mixed numbers into improper fractions. Okay. Okay. Add or subtract, and then change the answer back into a mixed number if possible. Okay, so that's kind of one of the things that we want to do here is we want to put it in an easier context here, 3 and 5/8 and 1 and 1/6, which is just to change it up to an improper fraction, then do our regular subtraction there, and then or addition, and then change it back to a mixed number if we need to. Okay, now the question for us becomes is like, let's look at 3 and 5/8. We want to change that into an improper fraction. So what's that going to be there? What is that as a... That's correct. 29 over 8 is spot on. That is correct there. So again, how do we get that? That's going to be 3 times 8. Okay, so again, just take your big number times your denominator. Add that to 5, and you're going to put that all over 8. So this is for 3 and 5/8, so that's going to be, again, exactly 29 over 8. All right, and how about 1 and 1/6? What's 1 and 1/6 as an improper fraction? 7/6. Okay, good. That's correct. So what we have here is we have 29 over 8. Let's go with this here. So here we have 29 over 8 minus 7/6. Okay. So this is what we have here so far, just by rewriting both of those mixed numbers. Now, let's talk about the common denominator. What's the common denominator for these two fractions? Okay, that's correct. 24. Now, if you don't see 24 right away, that's fine. Again, you start at 8. We always start at the largest number. Now 6 doesn't go into 8. So we try the next one up with next multiple, which is 16. 6 does not go into 16, fortunately. So we try 24. And then we say, oh, okay, well, that definitely works, okay? 24 definitely goes into 8, and 24 also goes into 6. Okay, so, all right. Now, let's look at this here really carefully. What should we multiply the first fraction by here? How to make that 8 to 24? A 3. That's correct. So let's multiply both the numerator and denominator by 3. How about the second fraction? Okay, 4. Nice. Okay, so we'll multiply the numerator and denominator by 4. Sounds good. Okay, so we have 29 times 3. And so we got 29 times 3. That's going to be 87. Yeah. What happened? Oh, go. So this is 87 over 24 minus 28 over 24. Okay, so just doing that multiplication. Put that together, we get 87 minus 28 on the top over 24. Keep that 24 the same on the bottom. And what do we get here? We get 59. I think we get 59 here. So 59 over 24. All right. Can anybody tell me what 59 over 24 would be as a mixed number? What's 59 over 24 as a mixed number? 2 and 11/24. Good. That's correct. Now, if you're not sure how we came up with that, let's go ahead and talk about that here really quick. So where this comes from specifically, this comes from the fact that if we do, let's do that out here. All right. So if we do, say, in this case, 59/24, this is going to equal, again, put a 24 here on the outside, a 59 here on the inside. And so we go, 24 goes into 59 2 times, so that's 48. And so we get a remainder here of 11. So this 2 here becomes our big number here. This 11 becomes our numerator. This 24 here is our denominator. Okay. All right, so if you want to know how you find that specifically, that's how you can go ahead and do so. Okay. Questions about that problem there? So hopefully that's not too bad. Okay. All right. Next, let's talk about the next one here. Okay, so let's go ahead and do some word problems. All right, word problems time. And then we can see exactly what we're working with word problems, so that shouldn't be too bad. All righty. Okay, so let's take a look here at several of these problems. Okay. Let's take a good look at this one here, number 7. Okay. Oh, actually, I take that back. Which one did I want to do here again? So one of these I wanted to do specifically. Okay, yeah, there's that one. All right. Sorry, it was number 8 I wanted to look at. You know, I was looking at one of these earlier. I'm like, oh. Okay. All right, so number 8. While installing water pipes, a plumber used pieces of pipe measuring 2 3/4, 4 1/8, 3 1/2, and 1 1/4 feet. How much pipe would remain if these pieces were cut from a 14-foot length of pipe? Ignore waste in cutting. Okay, so in this particular case, let's talk about what we have to do here. What we have to do in this particular problem is for us to go ahead and, I don't know why it never does that. Anyway, what we want to do here is take this 14 feet and we're going to subtract it by each one of these values here for the pipe that we cut off here for whatever reason. Okay, so our thing that we're going to do here is we're going to take 14 and we're going to go ahead and subtract that by, let's go ahead and figure that out there. 14 minus 2 3/4 minus 4 1/8 minus 3 1/2 minus 1 1/4. Now don't forget, you can write 14 as a fraction as well. Okay, so 14 can be rewritten as 14 over 1. Okay, so don't forget that that's certainly possible. All right. And remember to write out all of these guys in improper form. And you could go ahead and put those together. Okay, so let me give you guys a minute here. Let's give it a try. You guys can see if we can get this subtraction down. Once you guys got an answer for me there, go ahead and put that in the chat. All right. Let's go ahead and write this out here. Let's see, that's gonna get. I'm gonna put these into improper form here. Yeah, there we go. All right, so we got 14 over 1, 11 over 4, 33 over 8, 7 halves, and 5 fourths. All right, the common denominator here for this particular problem here is going to be 8. Okay, so 8 is the common denominator here. So if we go ahead, we can multiply each one here by respective numbers here. Here, this first one will multiply by 8. Multiply this next one here by 2. This one we can leave alone because we have 8 already. This we multiply by 4. And this we multiply by 2. So we got 8 times 14. And so 8 times 14 is 112. Next we'll get 22 minus 33 over 8 minus 28 over 8 minus 10 over 8. Okay, so that's what we have here so far. Okay, let's see if that happens to be the case. So we're going to go ahead and take all the numbers here. 112 minus 22 minus 33 minus 28 minus 10 all over 8. So let's go ahead and look at see what we get. All right. There we go. All right. Again, you can use your calculator for this part here, as I fully expect you to. Okay, so putting that together here, we get 19 over 8. So we get 19 over 8. That's correct, 19 over 8. And then if we put that together there, we're going to get 2 and 3/8, which will be our final answer for this. So 2 and 3/8 is what we're going to be left over with by using our common denominator there in that instance. All right, any questions about that? No. All right. Let's go ahead and try. Let's go ahead and try one more here from this section. All right. Let's take a good look here at. All right. Let's look at 16 here. It says a cabinet 30 inches high must have a 4.5-inch base and a 1 3/4 inch top. How much space is left for the drawers? See the figure. So here's the figure right here. of this particular cabinet. So how would we set up this problem here for number 16? How would we set up this problem here for number 16? Let's try that out. Yep. How could we set up this problem? What do you think we could do here? Four and a half minus 1 3/4. Think about it this way. How much space is left for the drawers? So the cabinet's 30 inches high here according to the picture. So we want to take a look at this picture here. Let's make it a bit bigger. So you can see that you have this 30 inches here, and you want to actually take away both the 4 1/2 and the 1 3/4. So you're going to have 30 minus 1 3/4. Yeah, other way around, Dan. So you got it slightly backwards there. Okay, so let's see what happens here with this problem. Let's do it out and see what happens. All right. Okay. So here we get 30 minus 1 3/4. Okay, minus 4 1/2. We'll go ahead and do the same thing we did in the last problem. We'll go 30 over 1. 1 3/4 will be 7 over 4. 4 1/2 will be 9 over 2. What's our common denominator here for this? 4, that's correct. Okay, good. So we'll multiply this first one by 4. Keep that the same. Multiply this by 2. Spot on. Okay. So we'll have 120 over 4. Minus 7 over 4 minus 9 over, minus 9, no. Minus 18 over 4. Okay, so 120 minus 17, minus 7, excuse me, minus 18. So we get 113, so that's going to be 95 over 4. So 90 over 5 over 4 is, what is 95 over 4 as a mixed number? What's that going to be? 95 over 4, what's that? 23 and 3/4. Perfect. Nice job, everybody. That is exactly correct. Nice. Okay. Any questions about that? Any questions at all? Nope. All right. Okay. That's fine. That's fine. All right. Okay. Okay, next. Let's talk about next. I'm just thinking about what I was thinking about is our pace in the course. So just making sure that we're still on track for doing the things that we need to do. Okay. So next here, what we're going to be talking about here is chapter 3, and we'll get through part of it here today. Not too hard, of course. We'll talk about decimals here in chapter 3. Now, admittingly, in this particular chapter here, for the most part, let's think about it this way. Decimal time is pretty much like, if you're doing it practically in the shop, then it makes perfect sense that you're not going to be probably doing it by hand. You can make mental calculations, but pretty much if you're going to be efficient, I know most people use a calculator. As I mentioned earlier, they're usually posters on a wall to kind of reflect between a fraction and its decimal equivalent. Okay, those things can be fairly helpful in a workshop environment as they do let you get things done quicker and faster. Okay, so that's what we're all about here. Now, these talk about just kind of a basic adding, subtracting is this first section here at the very least. So we talk about section 3.1, again, adding and subtracting. So with adding and subtracting decimals, really, you're not doing a whole lot here. Again, the key here is to line up the decimals. But this is a trades course here. So being a trades course, again, using your calculator is pretty heavily recommended here because, again, we're trying to figure out efficient ways to kind of solve for this. But just to kind of show off a problem here, again, you just have to line up the decimals here like 1.234 plus, sorry about that. That looks pretty bad. Plus let's say 0.56. Okay, so again, I just line up the decimals here, put that decimal right below, and I just start adding just as normal. Okay. So yeah, it looks kind of awkward, but well, it is what it is. So 1.794 would be my answer if I added up those two decimals together. And the same rules apply for subtraction. Line up the decimals, get what you're looking for at the end of the day. So I'm going to leave that part to you for the simple stuff. Now, but we want to look at the applications of where we're going to be using this. So let's talk about those and let's apply it. Okay, so that's what we're really after here in this section. So let's do it out. Okay, so let's take a good look here at some dimensioning. Let's look at number 5. All right, it says to find A, B, and C. Okay, so find A, B, and C. Let's look at letter A. Letter A is right here, right where my mouse is. Okay, so this dimension here, from the center of this hole to this looks like the center of that hole. What is dimension A? What is dimension A going to be? make that slightly a bit bigger. There we go. (2.2). That is correct. Yes. So again, as you see here, the whole length here is 2.95, but the length here is 0.75, so you'll subtract those two from each other. And so what we're going to get here specifically is, move please. What you're going to get here is, again, 2.95 minus the 0.75. So that's correct here. 2.2 is spot on. Okay. How about B? What's B going to equal here? So what's big B going to equal here? So B is over here to the left. (45). I think you mean 0.45, right? So we got 1.87, which is the whole dimension, minus 0.95, minus the 0.47. So again, we take off the dimension of the 0.95 here and the 0.47. Subtract that, we're going to get 0.45. Again, I suggest you use your calculators for this so you get these done, as quick as possible. That's just fine. Okay. All right, let's try another one here. There's another one I want to do here. Okay. All right, let's do that. All right. Okay. All right, let's do that next one there. There we go. Okay, so the next one we're going to do here is we're going to do number 13. So 13 here, a piston must fit in a bore with a diameter of 3.375 inches. What must the diameter of the piston given the clearance shown in the diagram? So here is the here's the bore. The bore is 3.375 inches. And again, we want to be sure that the piston can fit within that bore given the tolerancing of the clearance in this particular instance. Can anybody give me an answer for this? So, excuse me, geez. Anybody got an answer for me for number 13? No, there's just a few of you here, but that's okay. Take your time if you're not sure. 3.37. That is correct. Very good. So in this particular instance here, if we look at the figure, we have 3.3750. That's right. Like I'll be honest with you guys, I don't care if you get it right or wrong. It's just a matter of me just checking to see if you guys, understand it. That's really what it's about. So right or wrong is like I don't need like perfection. I just want to see where I can help you improve. That's all. So don't be scared to answer. So if we subtract those two off, then indeed we're going to get 3.37 here as our final result. That's correct. Okay, so that isn't too bad. Good stuff. All right, questions about that? No? Okay, that's perfectly fine. Okay. Okay. All right, next. Let's talk about the next one here. Next one here talks about the next section here, which again, these sections for decimals are not super long. Um, so section 3.2 here talks about multiplying and dividing. So basically with multiplication and division, um, dividing decimals here, let's talk about the key to multiplication. Key to multiplication for decimals here is just simply going to be, well, it's pretty simple. Just add up the number of decimal places. So and then the key to division is basically to move the same number of decimal places in each number. All right. Now, I'm not going to go over this necessarily. It's not like super hard to do because, again, I'm thinking more on the practical side of things. So the practical side of things pretty much is telling me, saying, okay, hey, we're going to be using a calculator with this anyway. So we could talk about basic examples here. And while that's good, um, again, we want to be able to, again, a practical purpose here. Essentially, I could show just one example, I guess, of each really fast, though. Um, so you'll see how this looks like in action. Hang on a second. Thank you. Nope. All right. Check that fan later. All right. Good stuff. All right. Good stuff. All right. Okay, so next. Sorry about that. My fan was acting a little wonky. All right. So if we talk about multiplication, multiplication is, again, pretty easy here. Again, you have, let's say, 2.1 times 1.37. Okay, then this is one decimal place. This is two decimal places. All right. So in total, you'll move three decimal places if you go ahead and multiply these out. If you multiply these, you treat them like regular whole numbers. So this would be 21 times 137, for example. So you do 7 times 1 is 7. 7 times 2 is 14. Okay, go here. Okay, 3 times 1, 3. 3 times 2, 6. So we get 1 and 2. All right. So we add here. Then all we have to do here is move 3 decimal places to the left. 1, 2, 3. Okay, so if I were just to randomly multiply these numbers together, I get 2.877. Easy peasy lemon squeezy. All right, so I'm not talking about things that are like super hard here, but again, just talking about things that, pretty straightforward here at the end of the day. Division works the same way. If you have, say, 1.5, let's say 1.5 divided by 0.2, 1.51, let's say, divided by 0.2. Put the 0.2 here on the outside, put 1.51 here. Want to make this a whole number, move this over by 1 as well. So you transform the problem into dividing by a whole number here. So you get 15.1 here. And so 2 goes into 15 7 times. That's going to be 14. That'll be 1. Bring down the 1. So 11. 5. Number 10. Get 1. You can bring down another 0 here. And so you get like 7.55. Okay, so again, this is how you do it by hand. Now, I'm not going to expect you to do it by hand here. I expect you to use a calculator. But again, showing you an example of each. There you go. That's the process on how you would do that by hand. All right, now, let's do an actual practical example. And let's see how we can met this out. So, okay. Okay. Yep. All right, so the first one I want to do is number 158. Let's go to 158 here. Okay. So we're going to go ahead and do number 17. So a room addition requires 320 square feet of wood floor. Hardwood costs $4.59 per square foot, while laminate costs $2.79 per square foot. What is the total difference in cost between the two types of flooring? Okay, so what would you do here in a problem like this? Multiply first, okay? Sounds good. So let's multiply 320 by 459. All right, so let's do that. So 320 times 459, what's that going to be? How much would it cost us for to buy the hardwood? Yeah. So what would be the hardwood cost in this particular case? All right, 1468. All right, good. Let's try the other one. So 320 times 279. All right, so far so good, everybody. Now let's find out how much it's going to cost us if we go laminate instead. What do we get there? $892.8. Okay. So $892.80. Perfect. All right. So if we subtract those two from each other, again, let's find out the total difference in cost. So let's subtract the 1468.80 and the 892.80. Let's see what we get for that. $576. All right. Good. So the difference in cost here is $576. I have laminate flooring. Laminate flooring is much easier to maintain. That's true. All right. Okay, next. Let's talk about the next one here. Okay. Okay, so next here is going to be, let's see, which one is that one? Right. Oh, yeah, okay, that was that one. All right. Let's go ahead and do one more here. Let's do number 11. Okay, so number 11 says a total of 12.4 gallons was needed to fill a car's gas tank. The car had been driven 286.8 miles since the tank was last filled. Find the fuel economy in miles per gallon. All right. So can anybody tell me what would the answer for this one be? What do we get for this one here? Number 11. 23.9? Okay, good. That's right. So our answer here is going to be 286 divided by 12.4. So 286.8 divided by 12.4. All right. And then we do that out. We get 23.9 or about thereabouts. So let's confirm that here. Where's that calculator? Mine is on my phone. So the one that I have is in my bag right now. All right. 23 point. Oh, we want 23.12. Wait a second. We want 23.1 is what we want here. So we want 23.1 I think you accidentally put 9 there. Yep, okay. Just making sure. All right, good stuff. Okay, any questions about that? Hopefully that isn't too hard to do. Nope. Okay. I didn't think that would be very hard. Okay. Now, that one there isn't super important. Okay. Yeah, that one I do want to do on separate. Okay. Okay. All right. So, any questions over those 3 sections there? I know there's not a lot in each of these sections because of, we're pretty much just kind of scraping by pretty quickly. So it really doesn't require, honestly, it doesn't require all that much effort for most of these sections, kind of in the middle. Really, things will start to ramp up. Like, honestly speaking, things will more ramp up once we pass, like, once we get to chapter 5, things will ramp up to a little bit more difficult side of things. So, that's once we get to chapter 5. Like, the first 4 chapters here are pretty, like, boom, 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 pretty straightforward. Things that you probably have heard of before. Um, most of it's like none of it's like brand new to most of you. So it's like, well, oh, it's there, and you're like, okay, it's there. That's great. So we're pretty ahead of the curve here. So uh, let me go ahead and ask you guys here what you guys would like to do. Um, if you guys just kind of want to uh, stop here and then be like, okay, we just start with the last part of chapter 3. I want to do the last part of chapter 3 with chapter 4 because they have stuff to do with each other. So, what do you guys think? What do you guys? Up to me? Okay. I know we haven't gone on too long today, but yeah, there's gonna be days like this where it's like, yeah, there's just not a lot of material to go around, in all honesty. But there'll be days where we are gonna have a lot of material. So stop here. Okay, that's fair. I'm guessing it's because you want to take a nice little lunch break. Of which I don't blame you whatsoever. Um, all right. So that's what we're going to do here. We're going to go ahead and stop here for today then. We're going to start up at section 3.3, which is the end of chapter 3, and then we'll get into the first half here of chapter 4. And then, like right once we're done with chapter 4, we get to chapter 5, things will start getting slightly a bit more difficult after that. Okay? So a nice easy Monday, okay? A nice easy Monday. I know most people don't like Mondays. I'm not a big fan either. But a nice easy Monday, I think sounds pretty good. Yeah. All right. Any questions before we head off here for the day? Yeah, I certainly can, Brendan. No problem, my man. Absolutely. Go ahead and save that now. All right, I will email those to you right now, actually. Here we go. There you go. What do we do in MyLathab? Yeah, so the sections you want to do is section 2 point, get that one more time here. Hang on a sec. Sections, yeah, okay. So sections 2.4, 3.1, and 3.2. If you want to kind of keep up with the work there, is what we did here today. I also sent you the notes there, Brenton, so you should be good to go. All right, no problem. No problem. All right, good stuff. All right, everybody. I want to thank you all for coming out here once again. I know today is a pretty short day here today, but a nice relaxing Monday isn't so bad either. All right, everybody. We're going to come back here on Wednesday. All right, same time, same place, 10 o'clock. All right. Thank you very much. All right, so have yourselves a great morning and afternoon. All right, and we'll see you again next time. Okay. Yeah, have a great one. We'll see you in a couple of days. All right. Take care of yourselves, everybody. Have a good one. We'll see you later. All right. Bye.